All right, so in this first one, this is going to be looking at how we construct the Lewis diagrams for atoms. So there's a bit of a process to do for this. So if we are given an atom, let's say, for example, chlorine, and we're asked to give the Lewis dot diagram for this. What we're looking at is a Lewis dot diagram shows us the bonding electrons. Not all of the electrons, so that means it is only the electrons in the valence shell. So the first step that I'm going to have is to write down the symbol, because that symbol is going to be where I find it on the periodic table. So my symbol, of course, for chlorine is Cl. And I find that on the periodic table over here. All right, so that's part of my periodic table. What I do to find out how many electrons it's got, sorry, one. What I do to find out how many valence electrons it's got is I go to the very start of its period, and then I just count which atom it is along, and it's 1, 2, 3, 4, 5, 6. It's the seventh one across. So then I'm able to put those in. So I've got 7 electrons. Seventh one along, so I've got 7 electrons. The electrons are arranged in 4 planes. So with a pencil, I'm going to draw those 4 little lines. They're going to disappear soon. Then I start putting them in one next to a line at a time, and then if I've still got electrons left over, I start pairing them up. So I've got 7 electrons. 1, 2, 3, 4. I've still got 3 left. So 5, 6, 7. Then what I do is I rub my pencil lines out, and I've got my Lewis structure for chlorine. Let's say I had carbon, because carbon is a very commonly used one. Carbon is number 6. So when I go across to where it is, it's 1, 2, 3. It's the 4th one along in the second period. So I've got 4 electrons for this one. So following the same process, carbon is C. I put my 4 pencil lines in place, and then I put my 4 electrons around, 1 per line, and if there's any left over, I double them up. So 1, 2, 3, 4. Then I rub my pencil lines out. You'll sometimes see carbon with those electrons put in the middle. That makes it hard to understand its bonding. This actually shows why carbon can make 4 chemical bonds, because it's got space to pair up here to make a chemical bond, and here, and here, and here. So those are the 4 places that carbon can make a chemical bond or a covalent bond by sharing electrons with another element. So that's why we use the 4 planes or 4 bits of 4 pencil lines. So let's go through that process quickly. Step 1 is actually to identify the element, so the symbol of the element. Step number 2 is to find it on the periodic table. By doing this, it allows us to work out how many valence electrons it's got. Once we've got that number of valence electrons, we can arrange them. So our next step then is to draw our 4 pencil lines around the symbol. And then we put the electrons in, 1 per line each, and then we've got leftovers, we start doubling them up. And we call that doubling up paired electrons. So when they're doubled up, they're paired, which is actually quite a stable arrangement. Then our last step, because the lines are not part of our Lewis structure, is to erase our pencil lines. We have our Lewis structure.
For ones that have just got like the 1 each, does it matter if they're in the centre or do they have to be kind of off centre?
Look, you're not going to get marked out for them being off centre or off centre. It's just that they're in the right plane, as it were. So you've got boron as an example there, haven't you? Yeah, so for example, if you drew boron, if you had them off centre like this, that's really good because it shows the 3 bonds, the 1, 2, 3 bonds that boron can do. But if you drew it like this, that's fine. That's absolutely fine. You just might find it harder to do the next step, which is creating molecules with it. Okay, so either of those would be correct. In fact, with boron, because it's a special case, and that it only makes 3 chemical bonds, you could get away with it like that as well. But boron's a very special case. And that's the last thing I want to go through, is that most atoms and molecules are going to end up making 4 chemical bonds. We'll do that in the next bit of teaching. But hydrogen, beryllium, and boron are exceptions in that hydrogen can only make 1 chemical bond. Beryllium can only make 2 bonds, and boron can only make 3 bonds. As I say, we'll get into that when we do molecules, exceptions. Everything else is going to end up making 4 chemical bonds, because 4 times 2 is 8, and we have a thing called the octet rule. We'll do that one shortly. Any other questions before I stop there? Awesome.